Did you know the moon is actually lemon-shaped? Despite its round appearance in the night sky, our natural satellite has flattened poles and bulges around its equator. The Milky Way smells of rum and raspberries. In 2009, astronomers discovered a giant cloud of ethyl formate at the center of our galaxy, giving it this unique aroma. On Mercury, a day is twice as long as a year. Due to its eccentric orbit, a single solar day on Mercury equals 176 Earth days. Surviving in space without a suit is possible, but only for a couple of minutes. The vacuum would cause your blood to boil and your body to swell, but it wouldn't be instantly fatal. A teaspoon of neutron star material weighs more than the entire human population. These stars are incredibly dense, packing trillions of kilograms into a tiny space. Gamma-ray bursts release more energy in 10 seconds than our sun will in its entire lifetime. These intense flashes of radiation are the most powerful events in the universe. There are stars we will never see. The universe's expansion means some stars are now too far away for us to ever observe, even with the best telescopes. Black holes have theoretical opposites known as white holes. Unlike black holes, white holes are thought to expel light and matter. Jupiter's magnetic field is so large it would appear bigger than the moon in our night sky if it were visible. This massive magnetosphere is filled with plasma from its moon Io. Neptune has only completed one orbit around the Sun since its discovery in 1846. It takes 165 years for Neptune to complete a single orbit. Planets can wander through space without a parent star. These rogue planets drift through the galaxy, having been ejected from their home systems or formed independently. The Sun loses 1 billion kilograms of mass every second. This mass is shed as particles in the solar wind, equating to 1 Earth every 185 million years. Most Sun-like stars are part of multiple star systems. Unlike our solitary Sun, over half of these stars have companions, forming binaries or triplets. Vast amounts of water have been found in space. Moons like Europa and Enceladus have underwater seas, and a black hole 12 billion light-years away is surrounded by water vapor. There is gravity on the International Space Station. Astronauts float due to the ISS's continual free fall, not because there's no gravity. Our days are getting longer. Earth's spin is slowing, adding 1/500th of a second to each day every century. The moon is moving away from Earth. It drifts 3.8 centimeters farther each year due to gravitational interactions. Heat from the Big Bang is still around today. This cosmic microwave background radiation is a remnant of the universe's birth. Venus spins backwards. Unlike other planets, Venus rotates in the opposite direction, possibly due to a massive collision in its past. Uranus is the coldest planet in the solar system. Despite being farther from the Sun, Neptune is warmer than Uranus. Black holes give off light. As material falls into a black hole, it heats up and glows, creating bright accretion disks and jets. 5 billion suns could fit inside Uy Scuti, one of the largest known stars. This red hypergiant is 300,000 times brighter than our Sun. The Moon's shape was influenced by early interactions with Earth. Its lemon-like form is a result of gravitational forces during its formation. The Milky Way's ethyl alcohol cloud could supply 300,000 pints of beer per person per day for 1 billion years. However, it also contains toxic chemicals. Mercury's unique orbit causes extreme temperature variations. Its long days and short years create a harsh environment. Exposure to space would cause rapid cooling and swelling. The low pressure and lack of oxygen would be fatal within minutes. Neutron stars are remnants of supernova explosions. Their incredible density is a result of gravitational collapse. Gamma-ray bursts are linked to massive star implosions and neutron star mergers. These events release unimaginable amounts of energy. The universe's expansion is accelerating. This discovery has profound implications for our understanding of cosmology. White holes remain hypothetical. Scientists are still exploring how these objects could exist in reality. Jupiter's fast rotation contributes to its strong magnetic field. This field interacts with the solar wind, creating a vast magnetosphere. Neptune's long orbit highlights the vastness of our solar system. Its slow journey around the Sun contrasts with the shorter orbits of inner planets.